There are two of these valves used on the bike. One controls the fuel tank pressure and the other one controls a fuel supply direct through the side of the carburetor and into the turbocharger. The valves are both based on the same castings, which I designed, had cast, heat treated and then machined up myself. This particular valve is the one used to supply fuel to the carburetor once a certain boost pressure is reached. Here you can see the valve in operation. As I increase the pressure, the piston is pushed back and you can see the needle is pulled back into the body of the valve. I have now adjusted the spring so that the valve starts moving at about 10 psi, which is the marked graduation on the gauge. So as we turn it up, see the needle is not moved, and as we approach 10 psi it starts pulling back. So it's very easy to adjust the point at which it starts opening and closing. You may be able to hear it, but there's quite a bit of air actually leaks past the pin. Which would, in use, be leaking down this tube here going to the carburetor. And once this pulls back and opens and lets fuel through this jet, it will then go down this tube with the air. So what's actually fed to the carburetor is not just a stream of fuel, but a stream of fuel and air, which helps speed up response. So as soon as this opens, the air is already flowing, it just adds fuel to it and makes its way to the carburetor very quickly. It's only a short piece of tube. In fact, this piece of tube is probably the bit I used. When the pin and the needle are fully extended, which they are in this shot, the needle goes down the main jet, just a little Mikuni hex head jet, and the rubber O-ring on the end seals up against this face on the jet. So any fuel coming in here, which is from the tank at approximately 5 psi, is stopped from flowing through this jet until this needle pulls back and the O-ring unseals it. So the initial flow is set by the size of the jet, the diameter of the needle, and that doesn't start until it actually moves. And then the taper gives you the fuel flow progression as against boost, as does the spring inside here. These are the parts as cast and heat treated for the main body of the valve. The material used was LM13 and they were heat treated to T6, I think. Whatever, it made it very easy to machine with a very nice finish. So these valves were an idea I had well over 20 years ago now. At that time I liked to write things down on paper and make a few diagrams and bounce ideas off people. So these are the notes. I've actually still got them from that time when I was actually thinking about this and putting ideas together. Here's the valve partially disassembled. You can see the spring, the little retainer, and the fuel inlet at the bottom, and the piston with the pin screwed into it. Here we have the end plate with the bolt that adjusts the spring pressure to set the start point for fuel flow. This one here is of the end plate with the spring and the small retainer that's used to just locate the spring on the bolt. Works pretty good. And just an outside shot of the adjustment bolt. This piece was turned up from round bar and is the fuel inlet and the small jet through which the fuel is actually metered. Just another shot of the same device. There's a small register there to make sure that when it's all screwed together that it's concentric. all the way through the valve. Inside the piston, you can see where the pin is screwed into it. There is a washer which the spring sits over top, and then a nut to lock the whole lot into place. As you can see, there is no O-rings or any other sealing on the piston. It relies on a close fit, and typically I just put a lick of grease in there to seal it up and make sure it doesn't seize. Seemed to work pretty good. Initially my thoughts were to machine the pin as a separate piece from the needle and possibly use carburetor needles glued into the end of the pin, but the end result was that I actually machined them all as one piece, so the pin and the tapered needle are all one. Here you can see the small O-ring around the tapered needle. This one's been in place for quite a while and has been flattened out. I did think about fully machining the whole valve, but in the end I decided not to, as I quite like the look of the rough sandcasted part versus the machined part. Looking down inside the valve, at the 3 o'clock position down the bottom, you can see where the air comes in right up against the end plate at the other end. And here you can see the rubber seal in the end plate through which the pin slides. I machined this valve on an old lathe which I owned at the time, so I needed to make registers on every mating surface so that everything was concentric once bolted together. Here you can see the piston more or less where it would be with the valve closed, and you can see at about the 2 o'clock position the inlet port opening to the area under the piston so it can be pushed back up against the spring.